Today we'll be talking about, I will begin by talking about Washington's volcanic hazards, followed by our earthquake hazards. Forgive me, my coffee hasn't quite kicked in yet, but it'll get there in this morning as I talk about earthquakes and volcanoes. And then Alyssa, my coworker, will introduce herself and talk about Washington's tsunami hazards, and then some preparedness and resources where you can learn more about this. Basically, we have a really interesting and exciting state we live in, but we want to make sure you are equipped with the resources you need in order to be prepared for them. These seem huge, volcanoes, earthquakes, tsunamis, but you can be prepared for these if you take the time now to learn about them, and everything that you and your family can actually do to be ready for these. We'll follow that up with some questions and answers with whatever we have time for. But again, please feel free to put those ahead of time in the chat as they come to you. We'll keep moving through the presentation. So I'm going to start right off by talking about our volcanoes in Washington. So first off, just to have a question for everybody. Can't quite respond, but does anyone recognize this mountain? Because this is a pretty famous peak. We got this nice symmetrical cone. It looks very similar to, say, Mount Rainier or Mount Adams. However, this is Mount St. Helens prior to 1980. This is what this mountain looks like now. And I just like to start off with this reminder when talking about our volcanoes that they can very dramatically change our landscape. We hear a lot of stories about Mount St. Helens before. This was Spirit Lake. A lot of people spent their summers here. They recreated here. They went on sailboats. They spent time at a cabin. They went to summer camps. This was an important part of the culture of Washington, especially in the southwestern part of it. However, it very dramatically changed. Now, this and all of our other mountains, all of our other volcanoes have been a huge part of Washington's culture for thousands of years, all the people that have lived here. But this is just a reminder, as we saw on May 18th, 1980, that they can very dramatically change what they look like in a way that unfortunately can result in lives lost, as 57 people died on May 18th, 1980. So our volcanoes are separated into different threat levels by the United States Geological Survey Cascades Volcano Observatory. I'm going to mention them a lot as USGS CVO. So if I say that, that's who I'm referring to. But they've looked at our different volcanoes and compared them based on how many people they put at risk, how often they erupt, as well as just kind of what kind of hazards they have. And based on that, they've categorized all the volcanoes, 161 volcanoes that are monitored in the entire US by their 5 observatories. Cascades is only one of them. There's also California, Yellowstone, Alaska, and Hawaii volcano observatories. But based on that, our volcanoes, we have 5 active volcanoes in the state. And where they rank, Mount St. Helens or Lewitt or Luetla, is ranked as number 2 in the US. Kilauea, ranked as number 1. It just erupts so frequently, and people actually live right on the slopes. So that's considered a higher threat than St. Helens. Mount Rainier or Tahoma, considered number 3 in the United States, not just in Washington. I mean, it's pretty close with St. Helens, about 90,000 people at risk from its lahars, which we'll talk about, but it falls behind St. Helens because it does not erupt nearly as frequently. Mount Baker or Kulshan, number 14. Glacier Peak or Dacobed, number 15. So those two, again, very close to each other and also very high threat. We move into the high threat category next with Mount Adams or Pato, which is number 34 in the United States. So all of our volcanoes, all of our 5 active volcanoes are in the very high or high threat. Now, what does that mean living with these? That's what I want to help you learn during this presentation. So if we look at our 5 active volcanoes in comparison to the rest of the Cascades range, here's a nice thing that USGS CVO put together. So each of these little volcanoes right here represents a period of eruption. Again, an eruption is not just boom and it's done. 1980, we like to think about May 18th, 1980 being the one thing that happened, but there were explosions before that. There was about a month and a half of activity, and that was not the last thing the volcano did either. It started erupting again in September. So 1980, the entire period is probably one of these little guys here, one of these little mountains. 1986, it had another eruption. 2004 to 2008, there was another period of eruption at Mount St. Helens. That's why there's so many of these here. And again, it's number 2 just because of how frequently it's erupted. Looking at our next highest, Mount Rainier here, this has had a lot of eruptions in the past 4,000 years. And just for reference, this red line right here, this represents the past 200 years. So you can see all of our volcanoes have erupted in the past 200 years. It's potential that Mount Rainier's eruption will be removed from the record. USGS is having difficulty finding any evidence of that. It was kind of something that settlers saw. Just based on the events of last year, maybe they saw a cloud over Mount Rainier and thought it was erupting. That was a fun day. It did not erupt last year, by the way, in case anybody was concerned. But all of our volcanoes have had eruptions in the last 200 years, and they're all considered active volcanoes. All of them that have erupted in the past 10,000 years are considered active. That's what we mean here. All of them will erupt again someday. So that's what we want you to understand and what to be prepared for. Now, when we look at different natural hazards, when you get floods, you get a little bit of a warning before they happen. You get the weather warning. When we look at things like earthquakes, you don't get any warning, but they're aftershocks. They tend to last for years, tens of years. Can get a tiny bit of warning before an earthquake. I'll talk about that in the earthquake section, but that's only seconds. That's only after it's happened. So the thing about volcanic eruptions is I want you to keep one key word in mind, and that is uncertainty. There's a lot of uncertainty when our volcanoes begin erupting. So we know that they can erupt, but the biggest uncertainty is the timeline, exactly what's going to happen and when, what the volcano is going to erupt, and how long it's going to take for that to start erupting. And as emergency managers and as people living in the area, we have to start making decisions before we know exactly what's going to happen. So I like this graph as a way to show the volcano's heartbeat, its blood pressure, just what it's doing, the signs might be escalating that it's going to do something. Now that could be more earthquakes that are moving upward that indicate that magma is moving upwards in the crust. The volcano could be inflating. The volcano could be showing signs of increased heat. Now all of those could indicate upward movement on this graph here over time. And that could happen very quickly, that could happen very slowly. But we need to start making decisions. Do we evacuate some people out of the area of the volcano? It might be well behaved, it might erupt immediately, it might show these signs of activity for months before erupting. And then it could be like Mount Baker in 1975 that showed all these signs like it was going to erupt, and then it didn't. Don't remember that Mount Baker 1985 eruption? It didn't happen, but we did close the areas around there. The area around Mount Baker suffered a lot because they have a lot of recreation needed there. They closed the National Forest campgrounds, the ski resort area. All these things impact the area, and those decisions were made to keep people safe, even though we didn't really know what was going to happen, but there was definitely a chance there was going to be an eruption. So this is what happens when eruptions happen. How do we decrease that uncertainty as much as possible? Well, the USGS and the Pacific Northwest Seismic Network team up to monitor all our volcanoes, and that's really important. So one thing they monitor, as I mentioned, seismic. So they have these stations all over our volcanoes. They detect earthquakes, they detect tremors, because anytime that magma needs to move into these volcanoes, it has to break some rock to get through. Hasn't been there in a long time, so it actually has to break things that causes signals we can detect. They're kind of like earthquakes, but magma movement earthquakes definitely look a little bit different than typical regional earthquakes. They don't really have the P wave and the S wave you might hear about for other earthquakes. Deformation. So volcanoes move up and down. They inflate when magma is put inside of them, kind of like a balloon, although don't recommend putting magma in a balloon, not recommended. So things like GPS that you might use for driving your car, if you put two of those stations on either side of the volcano and they start to move apart, that might indicate that the volcano is inflating, that magma is moving into it. So those can be really helpful because they can be very sensitive to where you are. Then other things like gas. There's always gas coming out of Mount Baker, for example. You can see somebody monitoring it right there. Now, we know that long term it puts out a lot of gas there, but if the types of gas that are coming out or the amounts start to change, that could be a sign that magma is entering the volcano, a sign of volcanic unrest, which puts us in that period of uncertainty when more magma is going to happen, or more monitoring is going to happen. So all these things are to determine whether there is magma entering the volcano, putting it in a state where it might start to erupt. Our well-monitored volcanoes are not going to erupt without warning. That's what USGS assures us, and that's why they monitor so closely. Other things like if there's magma near the surface, the streams that run out of there from springs underground, they might warm up. They might get new chemicals in them. So, and then sometimes if something is really strange going on at the volcano, you might even be able to see it happening. Some of that inflation, like the huge dome growth before 1980 on Mount St. Helens, it's like that definitely looks different. There's something going on in there. But all these things are things that USGS, PNSN, and the people that live around the volcano, the national parks, really help us to understand. Besides knowing what a volcano is doing, it's really important to understand what a volcano might erupt. Now, you might have seen a lot from Hawaii, from Kilauea, from Mauna Loa recently, of these big lava flows quickly coming down the mountain. That's not what our volcanoes do here. So they erupt a type of lava called andesite, typically. It's named after the Andes. So you get this really sticky lava that comes out, flows very, very slowly compared to that. So Hawaii, 2018, that big eruption, they had rivers of lava flowing at 15 miles an hour. That's really fast. Some of these might be more like a kilometer a day, maybe a mile a day when these andesite flows are going down the mountain. But you can see the evidence of them if you look at Tahoma, if you look at Mount Rainier, you can see these huge ridges of black rock coming down them, and that's what an andesite flow is like. They just move very slowly when they're moving. When we're saying, what will the volcano actually erupt? Typically, the past is the best way to understand the present and the future, what we should be expecting. It's important to know what to expect. So we know that it only erupts those types of lavas, but we know as well that it has these other dangers, especially lahars, these volcanic mud flows, which we're going to talk about. So this is an example in the picture here to the right. You can see a really thick mud flow, and you can see the White River there. This is 31 miles downstream, and this is 26 feet of mud that has been left behind. And just see how big those boulders are that are left in there. Each of those is probably at least 2 feet, just based on the size there. And this is a deposit that came out of the volcano when it erupted, caused this huge mud flow to come down. So we know that that is a hazard from all of our volcanoes. So if we want to look at our maps here, we can talk about what hazards might happen at Washington volcanoes. The lava flows are not going to be something far-reaching, but if you look at one of these maps, so we got this pink area right around the mountain. That's a really important one to know. These are our near volcano hazards. I like to think of these as your disaster movie. If you ever watch Dante's Peak or Volcano or anything like that, these big clouds, the lava flows that are really close by, rocks flying out and hitting you. Near volcano hazards, very fast, very unpredictable, very dangerous. This is the area that will most likely be closed when a volcano goes into a state of unrest. If it is closed, please stay out of that area. It's for your safety. Those are very unpredictable. These red and yellow and orange colors moving down the rivers away from the volcanoes, these are lahar hazard zones. So considered downstream hazards on this map, but this just shows areas where those mud flows can travel. And I'll have more about those in a second. What we don't show on the map is volcanic ash. Now, that's those little tiny particles of exploded rock that can travel any way the wind blows. Typically going to go east in Washington, but as we've been seeing over the past couple days, especially in the fall, the wind can go in any direction. So this ash could blow towards you. Now, Mount St. Helens 1980, that blew all the way out into Idaho and Montana. But it didn't go to the west very much until September when it erupted again. So let's look at volcanic ash in a little more detail. It's not like smoke ash you've seen flying around in the air. It is tiny little pieces of lava that have been fractured by the explosion. So this explosion is so powerful it breaks the rock into dust. Small amounts are a nuisance, makes it hard to drive, can make it difficult and challenging to get around. Doesn't make breathing fun. It's not particularly dangerous, but not good for sensitive groups to be out. Large amounts of ash can be very dangerous. They can actually, 4 inches of wet volcanic ash is heavy enough to collapse a roof. So that can be very dangerous in the area of heavy ashfall. So we got some images here from USGS that show just some of the ash in the area. Some of you probably remember this happening in 1980 because this is what happened. We had ash fall on some of the farms. It's not great. It's not great for agriculture to ingest. It can wear down their teeth. It's very abrasive, not great to drive in. If you use your windshield wipers, it can actually scrape the glass because it is glass. Rubbing glass against glass is not great. So ash is going to be the biggest hazard from St. Helens and Glacier Peak, but it's possible at all of our volcanoes. A lot of people think because Mount Rainier, because Tahoma is the largest of our volcanoes, it's the biggest, most explosive. That's not the case. Its explosions are typically a lot smaller. However, again, those lahars, because there's so much ice on it, it can send a lot of water, a lot of mud and ash traveling far down the rivers. So that's its biggest hazard. Now let's look at those near volcano hazards again. So what we're talking about here, some of them are tephra, which is what we're going to call any heavy ash fall, any ballistics, anything flying out of the volcano when it explodes. For an example, in 2018, when Kilauea was erupting, they had an interesting headline that the volcano in Hawaii was going to spew fridge-sized refrigerators. And what they were actually trying to warn you about was fridge-sized boulders flying out of the volcano when it exploded, just to give you a sense of the force. But that's just a fun headline I always enjoy sharing. Just how big the rocks can be. Now, when we talk about those lava flows again, I got a picture of one here. You can see that it is kind of big and blocky, very slow moving. But some of the danger comes from that. If you go to the base of these lava flows, it's got a lot of gas in it. It can have some explosive force behind it, and it can break apart into rock falls or pyroclastic density currents, pyroclastic flows. These are your big clouds of gas, rocks, and ash that come tumbling down the mountain quickly, very fast, very hot. These are unsurvivable. And this is one of the main reasons you want to stay out of this area if it's closed. Again, they're not going to happen if the volcano is not in a state of unrest, not going to spontaneously get a pyroclastic flow. But if it's in a state of unrest, it's very important to stay out of there. And then debris flows, lahar initiations. Doesn't have to make it all the way out of the park to be dangerous. Debris flows can even happen seasonally at the mountain when you get a lot of snow melt. There was one at Mount St. Helens earlier this year, just a little mud slide that happened, but that caused a lot of damage to the road, which has just recently been reopened after this event that happened in May, left a lot of cars stranded. These happen at Mount Rainier very frequently too. If you're there and you hear the ground rumbling, it sounds like a train, you want to get to high ground as quickly as possible and just know that these are hazards in the park. The debris flows, they can happen even while the volcano is not erupting. These are dynamic events, dynamic places visiting our mountains. I want to understand that these are possible at all Washington volcanoes. So we're going to look at lahars in a little more detail here too. Volcanic mud flows. This name comes from Indonesia, where there's a lot of volcanoes, but they typically start a little bit differently there. So their volcanoes are very explosive as well. They get a lot of volcanic ash built up on the slopes, and then they have a monsoon season. When all the rain hits the slopes, it mobilizes the ash, and you get these moving downstream. So these are relatively fast moving, but they pick up water, ash, pieces of the mountain, any debris that they pick up along the way. Here they typically start because there's a lot of snow, a lot of ice in our volcanoes. And during an eruption, they can melt some of that ice and just send it moving downstream, and it picks up more as it goes. Mount St. Helens in 1980, actually, after that massive landslide that came off the mountain, it wasn't until about 4 hours later the lahars actually started in the afternoon, as those big blocks that were in them of ice melted, and that sent all this water and all this debris and all this ash moving downstream. And you can still see the impacts of that today. So these are most likely to occur with an eruption. Very rarely can happen without one, the big lahars that are going to reach outside the park. Can travel miles downstream. The biggest ones from Mount Rainier, they did reach our Puget Sound. The biggest ones from Mount St. Helens, we saw in 1980, they reached the Columbia River. So these are huge. They can go miles and miles downstream, and they spread out in flat areas and river valleys. They slow down, but you still need to get out of the way. Basically, the thought with a lahar, if you are in the zone, you need to get out of the way to guarantee that you will survive. Other things might not. And you're going to hear about tsunamis later. It's very similar to that. You just need to get out of the way if a lahar is coming as quickly as possible. Take your go bag and go. Highly destructive, and they're a hazard at all Washington volcanoes. Not everywhere. You need to check those hazard maps to see if you're in an area. It's just the river valleys that come off of there. So if you're in between, if you're in those ridges, that is a safe place to be, but know that route to high ground. Yeah, again, here is another hazard map where you can see that from Mount Baker, where some of the lahars will go. Again, just looking at some of the rivers there. And then you can see that Glacier Peaks hazard zone also goes into Skagit County and Hamilton, Burlington. And the colors here, the reds, most dangerous. Like most of these hazards, the biggest ones that happen are the least likely to happen. But so it's most likely that if a lahar occurs, it won't go all the way to Puget Sound. They have in the past, though, and we want people to understand that and be prepared. Then I have this picture in the upper left from Mount St. Helens. Now that lahar destroyed 27 bridges. So you can see the damage there. So after this mud moves through, it just kind of sits there. It acts kind of like concrete. And you can see that boulder with a rock hammer on it for scale, just to see how big some of the boulders it carried were. These are extremely destructive and can reach such a huge area and far downstream. So lahars, get out of the way. Volcano safety, in addition to getting out of the way of lahars, just understand what your volcanoes are doing. All of our volcanoes are currently at normal or background, but USGS CVO monitors them. Similarly to like floods and tsunamis, there's these levels of normal, advisory, watch, and warning. All our volcanoes are normal. They're doing what they normally do. Sometimes they have earthquakes. They're active volcanoes. They do that. Mount Rainier also has a lot of ice quakes. They can tell the difference because they watch them closely, and that's really important. If a volcano is doing something, they might issue an information statement. If, for example, they were watching I just like this as an example of how closely they're watching their volcanoes. A couple of years ago in the Three Sisters volcanoes in Oregon, they issued an information statement to say that there's an area about as wide, about a mile wide, has raised about an inch over a period of 6 months. That's a huge area that just raised a tiny bit, but they detect that. That's how closely they're monitoring. And in that case, it was just an information statement. It didn't even mean the volcano was going towards an eruption. They're certainly watching it more closely now, but just an example. Our volcanoes might go into a state of advisory if something appears to be moving towards eruption. Maybe that earthquake swarm that's normal is starting to go upwards. They're going to start watching much more closely, put more seismometers on it, measure gas more frequently, things like that, to tell if it might go into a watch or warning. Now, a volcano might be in a watch if it's exhibiting heightened or escalating unrest, or if it is erupting in a way that's not going to impact anybody. Sometimes you get these eruptions that are far away. For example, Kilauea is often at this state when it's just erupting in its summit caldera. There's a lava lake going on there, but there's no lava flows that could impact people. Kilauea is frequently erupting in a watch. But the second in 2018 that lava broke the ground in the Leilani Estates, it turned to a warning. It's more likely our volcanoes will be in a warning if they start erupting because people could be in danger. But just watch these systems and know. Now, these are not tied at all to the park being closed. That's going to be a decision of the national parks. Evacuations are going to be the decisions of your local emergency managers. So things like that. You want to be able to get alerted about that. If you would like to get these alerts, you can sign up for Volcano Notification Service from USGS CVO. It's a free service. You can find their website on our mil.wa.gov/alerts page, which you're going to hear a lot about throughout this because it's a really important place to go. So first preview. But yeah, again, if a place is closed, it is for your safety. Please avoid that area. The hazards are going to be really unpredictable in that time. You don't know exactly when they're going to happen. You don't know which direction, and they can evolve very quickly. So again, follow the guidance of volcano monitoring agencies and local officials. Know the hazards in your area. Study those hazard maps for your local volcano. Do you live in a hazard zone? Do you live, work, or play in a lahar hazard zone? Are places that you travel, work, or commute there? In the meantime, I just want to throw this plug in there. Again, we started with that picture of Mount St. Helens and just how important it was to everybody in their summer. If you live in Washington, your volcanoes are part of the culture here. So while they're not erupting, while they're in their normal state, go enjoy them because these are beautiful mountains that have been part of our history for a long time. And they're really fascinating as well. You can learn a lot from them. So study your hazard maps, know how you're going to get alerted, and just how you're going to get out of those areas. It's really good to practice your evacuation routes if you're in them. For closing volcanoes, I want to say, what will our next eruption be? And we can't say. We can't predict when these are going to happen. We just know that all of our volcanoes will erupt again. Even if it's not in our lifetime, they will at some point. Just add magma. That's what our active volcanoes are in a state of. But we just don't know when that's going to happen. So know how you're going to get alerted, understand your area and your hazards, and that will get you prepared. Next, I am going to move on to earthquake hazards in Washington and get a better understanding of those. They're kind of linked to the volcanoes in that they are here for a similar reason, But they're also a very different mechanism and will happen at a very different rate as well. So first, we're going to start off by saying Washington has the second highest earthquake risk in the United States. We're right behind California in earthquake risk. Now you might say, hang on, Alaska gets a lot more earthquakes than us. Now that risk is tied because we have the hazard of earthquakes, but we have a lot more people living in earthquake-prone regions than Alaska does. They get a lot that don't really do much damage to people or infrastructure. Now, if we had a major earthquake on our coast, if we had a major earthquake in any of our crustal faults, it would cause a lot of damage and it would put a lot of people at risk. So that's why we're the second highest risk here. And with that risk, we just need to understand what our earthquake hazards are. Most importantly, what we can do about them. So let's take a look at the three different kinds of earthquake types we are worried about here. So the big one, what you might have heard of, the big one or the really big one. Off our coast, we have the Cascadia subduction zone. So this is an area about 700 miles long from the northern tip of Vancouver Island to northern California, where the Juan de Fuca plate is subducting under the North American plate. So this plate is oceanic. It's a little thinner. It's very dense though. So when it hits our continental plate, as it's drifting around, as it's being forced towards us, it moves underneath. And you got to do the hand diagrams or it's not a geology lecture. But it moves down, and over time, as it's forced under, it gets stuck. And we can get this subduction zone earthquake when it suddenly slips. An earthquake is basically just any slipping that happens along two surfaces of Earth's crust. So that's a possibility. 700 miles slipping at once would be an earthquake of magnitude 9 or higher. Potentially, we could get an 8 as well. That's a smaller section. These have happened in the past, but that subduction zone earthquake is the big one. We'll have that in the tsunamis that Alyssa will talk about soon, right after this. But that's kind of what we think about with the big one. Now, because we have this subduction zone, as the downgoing plate starts to move down, some of the minerals release water. Now, when they release water, that actually acts as a flux in the mantle, causes the mantle to melt, that causes the magma to move up into the crust, which is actually why we have volcanoes and why they're pretty much all in this arc parallel to the subduction zone. But because of that water releasing, the plate also becomes brittle. And when the plate becomes brittle, it starts to bend and snap. So when it does that, we get an earthquake that reverberates through a huge area. So if anybody was here in 1949, 1965, or most recently 2001, we get these deep earthquakes like the Nisqually earthquake. Now those can be up to magnitude 6.8, magnitude 7. They're big earthquakes. They are deep, so they're not going to be as intense as the earthquakes that happen right on the surface. There's a little more distance before they get to us. Waves have to travel, they lose some energy, but they affect a huge area, and a lot of people are going to shake very hard when these earthquakes happen. Those are the most likely to happen. They happen every 30 to 50 years. So that's our most likely next big earthquake that will happen. Again, the subduction zone, we know our last one was 1700, thanks to a fascinating story from the natives that lived here, telling the story of the Thunderbird and the whale. They've known this has happened lots of times over the past thousands of years. But for this particular one, we also have a history of a tsunami that struck Japan. They didn't know where it came from. They called it an orphan tsunami, but they've recorded the history of exactly the date and time that this happened. And we can trace that back to January 26th, 1700. We know that is our last earthquake on the Cascadia subduction zone. It was big enough to send a tsunami all the way across the Pacific Ocean, as well as causing a tsunami here. So we know we can have those. They happen every 200 to 600 years. I wish I could give you a better prediction of exactly when it's going to happen so we could prepare, but really all we can say with that is we're in the window. The plates are locked. It could happen. It could happen during this talk. I really hope it doesn't. It could happen later today, next week, or it might not even happen in our lifetimes. There's about a 15 to 25% chance this earthquake will happen in the next 50 years. So finally, our other one we want to look at are crustal earthquakes. Now, if anybody's ever felt stressed in Washington, it's because we are crushed between all these plates. It's not about work or anything like that. Because we're crushed between these different plates, we get all these faults in our crust. So you will see things like cutting through Seattle, these red lines. That looks like the diagonal one, or Southern Whidbey Island fault. But we have a Seattle fault that goes almost right under I-90. There's a Tacoma fault. There's a Chelan fault. There's Devil's Mountain Fault. These are all over Washington, and they're very close to the surface. So there's a possibility that when these happen, very similar to the unfortunate earthquakes we had earlier this year, the very devastating ones in Turkey, the one in Morocco very recently. These earthquakes, when they're close to the surface, they cause very, very intense shaking. And we have these as well. They're a possibility. There's roughly about a 15% chance one of these will happen in the next 50 years. Our most recent one that was large was in 1872, which I'll have a little more about here. But as you can see, earthquakes are a whole Washington problem. This is something we can all experience at some point. 1872 is significant because of the Chelan earthquake. Now this happened and we got all these historical accounts of it. It was the last, or it was our first measured historical earthquake, because we had stories of like settlers running out of their cabins and things. And I mean, but people have had stories of earthquakes for much longer than that. This was just the first one kind of recorded in papers. Now you can see there's a lot of these earthquakes happening over the Western Sound. A lot of these are deep earthquakes, like Nisqually, like Tacoma Narrows earthquake, the Satsup earthquake in Grays Harbor County there in 1999. But you can see we have one in 2001. There was an earthquake swarm in Spokane, and they're still trying to find out what exactly is behind that. Faults are very hard to find. It is difficult to look under our feet and figure out exactly what's going on. And then these are not the only ones. We also have like the 1959 Hebgen Lake earthquake in Montana that shook eastern Washington. Got some significant shaking from that, or the Bora Peak, Idaho, or most recently the Stanley, Idaho earthquake caused some shaking in eastern Washington. So we can also get shaking from other states around here. The thing is, we want everybody in Washington to understand what to do and how to prepare for an earthquake, because there's a very good chance you will experience one someday living here. It's earthquake country. So the first thing to know, again, like the volcanoes, know what to expect. So earthquakes will strike suddenly. We can't predict them. We don't know exactly when they'll happen. There's times when you can slightly know that there's an increased chance of them, but that's typically just aftershocks. So everything will begin to shake. Lights will flicker. They can go out. Sprinklers, fire alarms might go on. Windows, glass might break. Objects will fly and fall off the shelves. People may be screaming. I mean, we rely on the ground beneath us being solid, being sturdy. If it starts shaking, that is a scary time. And it's absolutely okay to be scared when an earthquake happens. We just want you to practice what to do so it's in your muscle memory. So even when you're scared, you can do the right thing to protect yourself and your family. And then think of other things around you, trees, telephone poles, rocking side to side. Some things might fall over. If anybody's been in an earthquake, you know this is a very scary time, potentially. But knowing what to expect, knowing that it is an earthquake can help you react more quickly. So we just want you to know this can happen in Washington and how to prepare. Really big key thing we want to drill in here. Do not try to run when an earthquake happens. And you see a lot of videos of things happening in other countries, especially buildings collapsing. You don't want to be there. But based on our building codes in Washington, collapse is very, very unlikely in our buildings. And most of the injuries that happen during an earthquake are when people are running. If you've ever been in one of those amusement park situations, maybe a carnival where you get a fun house and the ground is like going like this, and it's kind of fun to try to step on the plates, and it has this nice rhythm back and forth that you can predict. In earthquake, the ground is accelerating back and forth, up and down, side to side in different ways, unpredictably. There's not a rhythm to it. You can't guarantee that the place you step is going to be what you think. A lot of people fall, injure themselves, break their legs, and as you'll hear from tsunami, if your leg is broken, it is going to be very difficult to evacuate to high ground. The other thing is being struck by falling objects, which is why the cover part of taking cover is so important. I'll talk about that in a second, just what to do in different situations, but do not try to run is the most important thing. You want to stay as close to where you are as possible to minimize the injuries and possibility of death from these areas. So when you talk about measuring earthquake, I'm going to go over this very quickly, but earthquakes have magnitude, earthquakes have intensity. So earthquake magnitude, you hear about that a lot, maybe the Richter scale. We talk about a magnitude 9 earthquake being absolutely huge. So this is a little comparison here. If you go, every time you go up in magnitude, because this is a logarithmic scale, you increase the energy by 32 times. So a magnitude 6 going up to a 7, 7 is 32 times stronger. And we have that represented by the area of the circles here. So the very little black circle in the middle going up, so the area of that circle is 32 times greater. Go up to a magnitude 8, you're going to get about sorry, I have this written here. So 1,024 times more than a magnitude 6. Um, and I didn't even do the calculation for what a magnitude 9 would be greater than a magnitude 6, but we're looking in the 32,000 times range. Just a lot more energy release. Each earthquake only has one magnitude, and it's a description of how much energy that fault slipping releases. We also have a measure called intensity, and I want you to understand this one is more important to you, where you are. So it's a measure of how strong it feels, how strong that the ground is shaking in your area, and how much damage it's causing in different areas. So each earthquake has one magnitude, but a lot of different intensities. Show what that means. So here's the modified Mercalli intensity scale. So each level from not felt, that's an intensity 1. So there might be a magnitude 9 earthquake somewhere, and you might be far enough away you don't even feel it. The description of that, the intensity could be described as you're feeling a magnitude 1 intensity, or an intensity level 1. But then they go all the way up from weak shaking to extreme shaking, which is very unlikely in our earthquakes, this extreme level of shaking, but we can get in the severe and violent levels of shaking. And our biggest earthquakes, those are going to last for a very long time, which does extend the amount of damage it can cause. But as you can see, a lot of these describe what people are feeling, how they're reacting, in addition to what kind of damage is going to happen in different types of buildings. So we can look at USGS shake maps, which show the potential intensity of an earthquake. So this is a prediction based on the fault, based on the ground beneath it, how it's responded in previous earthquakes. We can make an estimation of how much the ground might shake in different areas. So this is just kind of the mean intensity of what might happen during a Cascadia subduction zone magnitude 9 earthquake in Seattle, in northern Oregon, and in southern British Columbia. Canada is definitely going to be impacted by this as well. So you can see it's going to be the strongest shaking in that violent range on the coast and in the inner Salish Sea area. And then you still get the severe and very strong shaking in the inner peninsula. Typically, as you move further away from an earthquake source, the intensity is going to get lower. So again, but you can still see there's going to be moderate and light shaking as far east as Spokane. This kind of earthquake, the very big one, will have very strong impacts across the entire state. So this is one that we prepare for and that we want everybody to prepare for. We'll talk about preparedness for that. So what do those levels mean again? Oh, I will take a look back at that. When we're talking severe and violent, those very strong ones, slight damage and specially designed, typically a wood-framed house that some people might live in. Wood is flexible. It actually stands up pretty well in earthquakes if you're anchored to the foundation, which is a really important mitigation step. Making sure that your home is anchored to the foundation can mean the difference between a house that you can live in after an earthquake to one that you can't because it's knocked off its foundation sideways. But then you can see that there's a lot of damage in poorly built or not reinforced structures. You're going to get a lot of chimneys falling if they're not reinforced. Again, these are some of the reasons you don't want to run outside of the building because you put yourself in danger of all of these things happening. For example, 2001, pretty famous image of the Phoenix Underground, the Cadillac Hotel formerly, and Pioneer Square in Seattle, and just look what happened here. So this is an example of unreinforced masonry building. A lot of old brick buildings that were built very quickly. It was a cheap way to build. It stands up really well to gravity, but when that building starts swaying side to side, those buildings can peel away from the floor. Now, one thing I want you to look at really quickly from this building right here to the one next to it, the yellow building. The yellow building is also brick. However, you can see those little dots on there at about the floor level. Those are called rosettes. And what that indicates is that the wall has actually been secured. It's been pushed into the floor there. So as a result of that, when it started shaking side to side, the walls did not peel away from the floor in the way that it does in an unreinforced masonry. So that's just a simple mitigation tactic that made a huge difference during this earthquake. And if you think about the amount of money the building owner saved in there, not having to repair the walls entirely, that makes a huge difference. Even though it's pretty costly to do these retrofits, it is definitely worth it when an earthquake happens. So we're working on understanding exactly where all these unreinforced masonry buildings are. Unfortunately, a lot of them are schools in Washington, so we want to make sure that these are protected, that they're retrofitted before the next earthquake, which again, we don't know when that'll happen. Sooner the better, we retrofit. But you can also see from this image here, all these bricks in the sidewalk, people running outside the building, in so much danger of those falling directly on them. So that's another reason not to run out of the building. You can also see the glass might be breaking. That can be raining down on you as well. So just a few examples. Basically, with this earthquake, we were extremely happy or extremely lucky that this happened on a February Wednesday in the morning. If this had happened on a sunny Saturday in the middle of the summer in Seattle, where there's a whole bunch of tourists walking around on those sidewalks in Seattle, would have been a lot different. Still 400 people get injured in this earthquake by things falling, by falling themselves when they were trying to run places. This was a big earthquake. Fortunately, nobody died as a result of the shaking itself. However, a lot of that was luck. Luck plays a big part in these, and timing. So I want to share this video really quickly from New Zealand, just to see this building in the upper right and just how quickly that wall comes down as soon as the ground starts shaking. I'll play it again. Our friends in New Zealand are unfortunately much more used to earthquakes than us, but just watch that again. The ground starts shaking and almost immediately that wall peels off. So you do not want to be trying to run out of this building. These folks did not drop to cover and hold on, but what they did was move away from buildings into the street a little bit and very quickly reacted, which is good. And because of that, they were in a safer spot, but they just kind of watched their footing. Now I'll talk about drop, cover, hold on in a second, what we want you to do. But first, look, that happened so quickly. What if there was some sort of system that could allow us to have a little bit of time to know there's an earthquake, to know there's shaking coming? There is in Washington, and all of you have it available on your phones. You just might not know. So I hope that you walk away. If you walk away with one thing from this other than mil.wa.gov/alerts, I want you to walk away with the knowledge that you have earthquake early warning through the Shake Alert system available on your phone. And this is a really cool technology. So tell all your friends, tell all your family. This works in Washington, Oregon, and California. So how this works, it's not earthquake prediction, but when an earthquake starts on a fault, it has a P wave and an S wave. The P wave travels very quickly. It's basically a sound wave, just shakes the ground a little bit, but it's typically a precursor to an earthquake. Now, this travels about twice as fast as the S waves, which are shear waves. They do a lot more damage. They shake the ground a lot harder. Those are typically what actually causes all the shaking in an earthquake. So when this P wave moves through, the USGS, the Pacific Northwest Seismic Network, have put out seismometers all over Washington, really densely in urban areas, less densely, but still a lot more than they used to be. We have almost 2,000 seismometers contributing to this network over the state. Now, when that P wave passes 4 of these, it quickly estimates what the magnitude of that earthquake is going to be, where it's coming from, and creates a shake map for it. So you know which areas are going to shake with which intensities. And then what the system does is it sends an alert to all receivers in that area that says you are about to receive shaking. All the areas that are going to receive an intensity, shaking above a certain intensity. So if you get this alert on your phone, there's 3 ways to get it in Washington, I'll talk about in a second, but if you get this alert, it means that shaking is coming to you, and you should protect yourself accordingly. How much warning does that give you? Typically for most earthquakes that we'll get in Washington, it's going to be 10 seconds or fewer. If the earthquake's really close, you might get that alert after the shaking starts as well. Now, how is that actually valuable, you might ask? Well, we see a lot of people that spend those first couple seconds of an earthquake saying, is that an earthquake? What's going on? Now, if you get that confirmation that it's an earthquake, you don't have to ask that question, and you can just start by protecting yourself. But we want you to practice with this so that you do know to quickly protect yourself as soon as the ground starts shaking, as soon as you get an alert, so that you're protected when the shaking starts. So 3 ways to get earthquake early warnings from Shake Alert. These are all run by the USGS system. Other ones do not work in Washington yet. The first one, wireless emergency alerts. You might already have this on your phone. Hopefully none of you have turned it off, although some people might have tried to when you got an Amber Alert in the middle of the night and said, this woke me up, I don't want it anymore. So you all can receive earthquake early warning through this. However, wireless emergency alerts, if you've ever been in a crowded place when an Amber Alert goes through, you notice it hits different phones at different times. So I'm going to recommend getting one of these other 2 options on your phone if you want that fastest alert, if you want them to make the most out of it. Yeah, in testing in California for almost 30 earthquakes so far as well. Wireless emergency alerts does deliver them quickly, but these other two methods are going to be even faster. So if anyone has an Android phone, congratulations, you have built-in earthquake alerts. It should be on by default. In these and MyShake app are tied with how quickly they deliver alerts. They've already both sent alerts to millions of people in California for their earthquakes. So California has been testing the system for us very well. Thanks, California. Sorry about all the earthquakes. Um, so you want to enable earthquake alerts on your phone for these. If you search for earthquake alerts or potentially for location settings, it will be in there somewhere. We have a couple videos on mil.wa.gov/alerts of screen recordings to show you how to find these, because it can be kind of difficult sometimes. Android does require your location services to be on. Again, you're only going to get these alerts if you're in an area that is going to receive shaking. It also has a test feature, so you can press a button, know what it's going to sound like. That's good to know. So when you hear that sound, you got to practice. The other one you can get here is the MyShake app. And because wireless emergency alert is the only other way to get this on an iPhone, if you have an iPhone, I highly recommend downloading the MyShake app. You can download it on Android too. Multiple ways to get alerts is better than none, that's for sure. So just as fast as Android app you download, it's free. Can use location services or set home-based location. So it also has a test feature, and for the upcoming shakeout drill, the MyShake app will be sending a test at 10:19 on 10:19. So I'm going to move through these. So again, these are only going to send you alerts if you're going to receive shaking. Wireless emergency alerts for only earthquakes magnitude 5 or above that are going to give you shaking intensity 4, light shaking or greater. So this graphic is available again at mil.wa.gov/alerts. But the big thing I want you to understand is if you get that alert, it means you are going to get shaking in your area. Finally, the system is not just meant to go to your phones. There's other places it's being sent. A couple schools in Washington already have this set up in their PA systems. Stanwood Camino Island, Acosta School just installed this as well on the PA systems. Maybe every student probably doesn't, not every classroom probably allows students to have their phones out all the time. But this is already being used in Japan, a similar system that we based Shake Alert off of that slows down trains to help mitigate damage to them, to help lessen the chance of a crash at full speed and minimize injuries. Things like returning elevators to the closest floor. We have this in some water and wastewater systems in Washington right now. Basically, this tool will help save lives if people use it correctly, but it can also help mitigate a lot of the damage and make sure that we have things available to help recover immediately after. So Shake Alert is in Washington. It's already working. It's on your phones. It's in several other places. And it is just an additional tool in addition to reinforcing our buildings, in addition to practicing your drop, cover, hold on, that will help us to get less damage and recover more quickly from the next earthquake. And you can learn more about this at shakealert.org and at our mil.wa.gov/alerts for specific Washington information. Again, seconds of warning are only valuable if you use them. California testing this for us, but we've also looked at some CCTV footage from California. And there are people that get this alert, pops on their phone, and they say, huh, what's that? I've never seen this before. And they don't spend that time drop, cover, hold on. And when the ground starts to shake, they're not protecting themselves. So that's only valuable if you use them. I could say we're in Washington. Even though they get more earthquakes in California, let's do better than them. We can do this. Make it a competition. So practice, use the Great Washington Shakeout to practice, which we'll talk about in a second. Overall, though, I want you to understand why we say drop, cover, and hold on during an earthquake, what that means in different situations. I know some people like to talk about situational awareness being more important than drop, cover, hold on. I would like to assure you that drop, cover, hold on considers situational awareness. What we mean when we say it is to drop. You want to get low to the ground. You want to be the one who gets to the ground. You don't want to be thrown to the ground by earthquake shaking. Drop is also important because you minimize your movement. You're not trying to run while the ground is shaking. Cover is about covering your head and neck and taking cover if possible. If possible, think about things like in your situation, the places you spend a lot of time. Is the closest cover to you? Is it a sturdy desk or table? Do you have a glass coffee table? You don't want to be under that, things like that. But a sturdy desk or table is going to protect your head and neck from just about anything falling on you, especially if you stay near the legs. Those are designed to protect, you can sit on a table. Things falling on it are not going to cause it to collapse or anything like that. You're creating a space for yourself if you need it, in addition to just protecting yourself from falling or flying objects. And hold on. Now, a lot of people that were in Nisqually say that it felt like it lasted forever. That was just 30 to 40 seconds of shaking. You want to hold on the entire time and stay protected, stay in that situation, keep your cover above you, keep your head and neck covered. Again, our Cascadia subduction zone earthquake might last 5 to 6 seconds of shaking. So anywhere you are, drop, get low to the ground, take cover, cover your head and neck. Even just grabbing like a textbook or something, if you have it nearby, cover your head and neck with that. They're important. And then hold on, stay in that position, hold your safety as long as the shaking goes on. Some weird ones like stay in bed. If you're in bed, you want to actually stay there. That is, provided you don't keep your bowling ball collection above your bed. You don't have heavy picture frames, things that are unsecured that can fall on you. Otherwise, your bed is one of the safest places you could be in an earthquake because you're already not moving. So it's a good place to spend 8 hours of our time, like 33% of our time. Think about that, the spaces where you spend the most time. What can you do to make them safer? If you're driving, for example, think about a lot of people in Nisqually said that they felt like their car got a flat tire. Now, if you get a flat tire, you want to pull over to the side of the road slowly. Same thing there. Just try to avoid, if you can, bridges, overpasses. Set that parking brake. That's kind of like your hold on. It's kind of like a cover. Now, if you're in a wheelchair or walker, if you have trouble getting to the ground on your own, that holding on is going to be really important. You still want to make sure that you are trying to prevent the ground from throwing you to the ground. If you can get down low, but make sure you're holding on to something as well to minimize that. Say lock, cover, and hold on. If you're using wheelchairs, lock your wheels. Maybe a walker, the same thing. So this works for anywhere. Think about that. And just think about the places where you spend the most time. What would you do if you were in your office, if you were in your bed, if you were in your home, if you were on your commute? Thinking about these now, getting them in your muscle memory, even practicing is a good idea. All right, and I am going to give this over to Alyssa to continue.
Thank you, Brian. So we've talked about two of Washington's major geohazards. I am now going to cover the third, which is tsunamis. These are primarily related to earthquakes and landslides, but not always. So kind of a quick tsunami primer if you are not familiar with this hazard. So tsunamis are essentially the displacement of a column or of a body of water, usually by an earthquake or a landslide, but we can also see them be caused by volcanic eruptions that are very close to the water or potentially underwater, like the Tonga eruption in 2022, which I'll talk about in a bit, or even certain weather events, meteor impacts, which thankfully we haven't seen in a long time, anything that is displacing that water. So earlier, Brian was talking about the Cascadia subduction zone. This graphic that's playing through right here is showing how a tsunami forms at a subduction zone. So when we get those locked plates that are building all of that, that friction and that energy, when they break and we get that big earthquake, that top plate actually snaps up. You can see it in this video. And when it snaps up, it's lifting that entire column of water above it, which depending on where it is in the water, that could be a mile or 2 miles of water that it then sends out, much like, the ripples in a bathtub or in a pond, in every direction. That's the tsunami waves. And so something that is so important to keep in mind with tsunami is that they are not just one wave. They are very long, multiple waves, series of waves that last anywhere from 12 to 24 hours or even longer, depending on how big that tsunamigenic event is. Oftentimes, that first wave that hits shore is not the highest wave, nor is it the most destructive. Some of our modeling shows us that for Cascadia, it's that third or that fourth wave that's going to be largest. And every time those waves move into land, they are picking up debris, cars, houses, trees, stuff like that. So when they come back in that next time, they're carrying all of those things with them. Tsunami waves are also very fast and very powerful. Out in the ocean, if they form out, in the deep water, they can move anywhere from like 500 to 600 miles an hour. That's as fast as a jet plane moves. They slow down when they reach shore and they start to stack up. But even then, when they're onshore, they can move anywhere from 20 to 30 miles an hour, which is a lot faster than most of us can run. And they are not like normal waves. You can see in the graphics and the bottom of this slide, these are really not like wind waves that kind of curve because they are pushed by the wind. Because it's that entire column of water moving, it's really like a moving wall of water that's coming at you. And because there's so much force in it, we tend to say it's kind of like a moving wall of cement with tons of debris in it. So very, very dangerous. They also leave behind a lot of mixed and hazardous debris. So even if those waves and the high currents that they cause are you have subdued after maybe 24 hours or 36 hours, a couple of days, there is still a very large impact to anywhere that's in that inundation zone because they leave behind a lot of debris. Now, when we talk about tsunamis, we are, for the most part, talking about very low probability events, especially when we're talking about the big one, that big Cascadia earthquake and tsunami. But they are very high impact events. So if you feel like you've been hearing about this earthquake and tsunami that's going to happen in Washington for years now, for decades, that's because we know it's going to happen. We just don't know when. But because it's a big, very high impact event, we want folks to be as prepared as possible. So because Washington has over 3,000 miles of beautiful coastline, which we love and enjoy every day, we are also at risk for both local tsunamis and distant tsunamis. And there are a lot of differences between the two, a lot of nuances. And so it's important to understand what those kind of differences are. So local tsunamis are ones that are caused by something basically kind of in or very close to Washington. So if it's an earthquake that causes them, that's an earthquake we're going to feel. That's occurring on one of our fault lines. It could also be a local landslide or something of that nature, but it's going to happen here in Washington. If it is an earthquake, that shaking, that ground shaking is going to be our primary warning that a tsunami could be on the way. That is our first warning. It's our best warning. It may be our only warning. For Cascadia, we're looking at potentially a lot of infrastructure damage, and all of the various folks who push out alerts are going to be trying to get alerts to you. But if our cell phone towers are down, if you don't have power or internet, or you're not home where you can get to your, NOAA weather radio, which I'll talk about later, you may not get those alerts. And so it's so important to know that if you are on the coast, near the coast, and you feel that really strong ground shaking, that's your warning. Don't try to get another alert. Don't listen for the sirens. Just head to high ground. What defines a local tsunami is also how quickly those waves arrive. So anything under 3 hours wave arrival is considered local. But when we talk about something like Cascadia or a tsunami that's caused by a landslide in Puget Sound, we're really talking more about waves that are arriving within minutes to maybe half an hour or an hour. Much, much shorter amount of time to get to high ground. Because those waves are arriving so quickly, they still have a ton of energy in them. And so there's a much greater impact to our coastlines. We see a lot more inundation on land, so that flooding on land. We see very powerful currents and a lot of destruction. Our biggest local threats when it comes to local tsunamis are that Cascadia subduction zone and then our crustal faults that Brian talked about earlier. We know that they have caused tsunamis in the past. We don't understand them nearly as well as we do Cascadia, but we're working on that. And one of those kind of big faults that we are looking at right now is the Seattle fault, which cuts right through Seattle and Bainbridge Island. We know that's caused tsunamis in the past, and I'll talk about that in a little bit. But so those are definitely a threat to both the inner and the outer coast. Now, for distant tsunamis, those are ones that occur somewhere else in the Pacific Basin. And so if they are caused by an earthquake, we're not going to feel that shaking. If it's a tsunami or an earthquake from Alaska or Japan or a volcanic eruption, in the Tonga Islands. That's not something that we know about unless we are getting official alerts or information from a news source. And so official alerts are extremely important for those distant events, because otherwise we're not going to know that we have something coming towards us. Usually those waves arrive in over 3 hours. For Alaska, which I'll talk about in a little bit, it's not much more than 3 hours, but for a large event, from the coast of Japan or something, we're looking at more like 10, 11, 12 hours. Because those waves are arriving from farther away, they lose some of that energy as they travel. And so we see a lot less inundation on land. We see kind of lower currents, not quite as much damage. So it's less impact to our coast. But as I'll talk about when I talk about Alaskan tsunamis, they can still have a big impact on our outer coast. So that's something to keep in mind if you live on the outer coast, or if you visit the outer coast, work on the outer coast. And when it comes to those distant events, Alaska really is our kind of closest and biggest distant threat, because they just have earthquakes so often and they are so close to us. So Brian covered the Cascadia subduction zone really, really well. But just for a quick overview again, 700 miles long, usually gives off a pretty big earthquake every 300 to 600 years. The last time was in 1700, so we are within that window. And right now we've got about a 15 to 25% chance that we will see a large earthquake on the subduction zone in the next 50 years. So that doesn't mean that it's a 15 to 25% chance that it'll happen today necessarily, but it's something that very well could happen in our lifetimes, could happen today, could happen in a decade. And when that happens, we are going to see major, major impacts. And that's why we hammer it so much when we are talking about preparedness. We are likely to see anywhere from an 8.0 to a 9.0 earthquake, potentially even larger. So that shaking is going to be from anywhere to 3 to 6 minutes throughout not just the state, but the West Coast. So when we talk about Cascadia, this is not just a Washington specific hazard and disaster that we are looking at. It's something that's going to impact Canada, Alaska, Oregon, California, and then a lot of our international partners in other parts of the Pacific. It's going to be very much a largely regional event. So that 3 to 6 minutes of shaking, that is followed, including that 3 to 6 minutes, by a major tsunami that hits our outer coast within 10 to 15 minutes in some areas. So not a lot of time at all to evacuate. And I'll show a video in a second that kind of gives you a better idea of what that wave arrival looks like. But when it comes to our outer coast, that arrival time really is just minutes. Another thing to keep in mind with Cascadia specifically is that because those plates have been locked for so long and they kind of pop and move when that earthquake occurs, we're going to see subsidence, so a permanent drop in the land, and then uplift, or an uplift of the land in different areas along our coastline. And that's going to be permanent to us, permanent in our lifetimes. And so that's really going to change the way that we understand our coastline, interact with our coastline. We're going to see quite a bit of subsidence on the outer coast that will change what that coastline looks like for us for many, many hundreds of years. So that's something to keep in mind, especially for the outer coast. Something else is that that's not just one big earthquake. It's going to be followed by many large aftershocks that will follow that main quake and in the coming months, and then thousands of smaller aftershocks for many, many years. Japan is still having aftershocks from their huge event in 2011. So this is going to be something that unfolds over time. If any of those major aftershocks are large enough, to create a tsunami, we might see additional tsunamis. Or if we get landslides occurring from any of those aftershocks, we might see more localized tsunamis. So something to keep in mind is that while we're talking about the big one, the big 9.0, and then the tsunami that follows that, there could be cascading effects from it that include additional earthquakes and tsunamis. So this video is a truncated video from Washington Department of Natural Resources that is showing kind of that main event that we plan to, that we make all of our modeling and maps to, which is a 9.0 earthquake and tsunami. So what this is showing you is once that earthquake occurs, what do those waves look like? We have time since the earthquake in the bottom left. It's obviously very sped up. And so I think it cuts off at about 6 hours. Obviously, those waves are going to continue. But it's giving you a good idea, kind of sped up, of what those first few hours of the tsunami will look like. And then we have the waves themselves, which the kind of darker red colors, that's wave amplitude. So how tall the waves are, capping out at 10 feet. So something that you want to keep in mind when you're watching this is that that's 10 feet or higher, could be 20 feet, 30 feet, 40 feet, as those very high waves. And then as we get into the colder, bluer colors, we're looking at the wave trough, or how low the wave is when the waves are pulling out as they reach shore, and that is 10 feet or lower. So it could be, 10 feet down, 20, 30. We will very likely see, vessels sitting on the ocean floor because the water has pulled out. One thing that I really like about this simulation, and that I think is pretty eye-opening if you haven't seen it before, is that especially when that first wave kicks off, you can watch it. It hits our outer coast real fast, and then it travels right through the Strait of Juan de Fuca. And once it hits kind of the Salish Sea and our islands, it breaks in two, and it travels up into Whatcom and Skagit counties, and then down into the Puget Sound. So although it is arriving in some of our South Puget Sound areas at 2.5 hours, we have much more time to get out of the inundation zone. This is something that's going to touch every part of our coastline and is going to continue to reverberate as long as those waves are still occurring, as long as the currents are still, high, kicked up because of all of that wave activity. So although we are much safer on the inner coast, we are still going to see impacts from those waves. And this is for that same 9.0 scenario based on DNR's simulation, wave arrival times, and then that amplitude offshore. So how tall is that wave when it is arriving and kind of hitting the shore? It's probably not super easy for you to read, but it's something that we make available, just giving you an idea. On the outer coast, you can see that there are some locations where the first wave is arriving within 15 minutes. And that's, again, including that 3 to 6 minutes of shaking where you're probably not going to be able to be running anywhere to get to high ground. A lot more time to get to the inner coast. But again, we are still seeing, some good amplitudes offshore on the inner coast. It's something that's going to impact all of us. Now, Brian mentioned the Seattle fault and some of our other crustal faults being a major earthquake hazard. And as I said, we know that they have created tsunamis in the past. So one thing that we are looking at now, the Department of Natural Resources working on, is tsunami scenarios for some of these crustal faults. We don't understand them as well as we do Cascadia, so that makes that modeling much more difficult. But we do now have modeling for the Seattle fault. And this kind of just gives you an idea of what that modeling looks like. Gives you an idea, we're going to see a lot of uplift on one side of the fault and a drop on the other side. So that's kind of why Bainbridge Island and parts of Seattle have some of their very big uplifted areas along the beach. This is kind of what we call the maximum considered Seattle fault scenario for Washington, meaning it has to be a very big earthquake for the Seattle fault to create a tsunami, and therefore this is a very low probability event. I want you to keep that in mind when you're looking at any simulations or mapping for this, because for Cascadia, we know it's going to happen probably in the next 100 or 200 years. And so that's the one that we focus on. We want to know the hazards and the impacts for the Seattle fault, but this is much lower probability. Keep that in mind. Now, when we talk about impacts, not just where we are going to see that inundation, when we're looking at those local tsunamis, like I said, they can cause a lot of destruction. So those tsunami waves, as well as liquefaction, which is kind of essentially when the ground itself sort of turns into mud or into water, And then landslides can cause a lot of damage to, our fuel systems and pumps. They can cause a lot of damage even to things that are outside that tsunami inundation zone if there is power loss because of that tsunami. We can see a lot of damage to our bridges, overpasses, our roadways, and a lot of our other vulnerable transportation infrastructure, because a lot of it is not really built to withstand both that 9.0 earthquake and that tsunami. And then, of course, because we, live in such a maritime community and economy here in Washington, we have a lot of marine and maritime infrastructure that is directly in the path of those tsunami waves. So we can expect that we would see a lot of damage to our ports and marinas, and the infrastructure there, which would impact, being able to bring goods into Washington and to send them out to a lot of the states like Hawaii and Alaska that depend on us. So we use the Japanese tsunami in 2011, which is what these two videos are from, as a good real world example of what that Cascadia subduction zone earthquake and tsunami could look like for Washington, because they have a very similar setup. It's a subduction zone that's pretty close off their coastline, can give very large earthquakes and tsunamis that strike within 15 to 20 minutes in some places. And so when we look at what happened in Japan, there are a lot of correlations between what we could see here in Washington. And just to give an example of what some of that damage looked like, they had over 2,000 roads and 56 bridges that were damaged, tens of thousands of ships that were destroyed, and hundreds of their ports either destroyed or heavily damaged, and took months or years to repair. And as you can see, in this top video, this is obviously a video taken in town. There are power lines, and yet this water is probably 10, 15, or 20 feet deep, and there are just these huge ships that are being carried through. We also expect to see a lot of high currents, even once the waves themselves have kind of subsided. And anywhere where we get kind of tight channels or bends in the water, like in the Puget Sound, where we have some very twisty waterways, we can get these huge whirlpools and currents that really kick up. So for anyone who is, a mariner, or, is interested or spends a lot of time on and near the water, those hazards will continue beyond just the tsunami waves. These are a couple other images from Japan, just to, again, give you an idea of the scale of destruction that they saw in 2011. And just give you an idea, unfortunately, of what some of our outer coast communities could look like. This is one of Japan's, low coastal communities. We also have a lot of communities on the outer coast that are right at sea level, that have those beautiful flat beaches, that unfortunately don't provide a lot of security from those waves. And so we work very closely with those communities to find ways to provide them with other means of evacuation. I mentioned before, we are at risk, of course, of any tsunami that kind of occurs within the Pacific Ocean basin, or we can be at risk from it. But Alaska is our biggest distant threat. Since 1900, Alaska has averaged a magnitude 8 or higher earthquake about every 13 years. That's really, really frequent if you are, in the path of potentially their tsunamis. I've got an image here from ocean shores in 1964, so that if you are familiar with the Good Friday earthquake, that was, of course, for Alaska, a local earthquake and tsunami that did an immense amount of damage. And then, because we didn't have necessarily great tsunami warning back in the 60s, that, struck Washington, Oregon, and California without a lot of warning, and kind of late at night, when folks would not have been able to look out and say, oh, there's something, coming in from the ocean. California got hit much harder than Washington did, but you can see here from the image in ocean shores that tsunami left behind a ton of silt and sand and debris. It destroyed at least one bridge. So still destructive, even if we don't see a lot of loss of life. Now, if we have a an Alaskan tsunami coming toward us because of one of their big earthquakes, we don't feel that shaking. So those official alerts are our primary method of knowing that something's coming toward us. It is mainly a threat to our outer coast. Depending on the angle that waves are coming from, it's pretty difficult for them to travel all the way through the Strait of Juan de Fuca and then, impact the Puget Sound or up into the Salish Sea in the same way that Cascadia does. When we look at kind of the potential, what is that sort of biggest or most likely scenario from Alaska, we look at something that is similar to that Good Friday earthquake in 1964, but with a slightly modified epicenter. So we take where that earthquake occurred and we just move it a little bit so that those waves are perfectly primed to hit Washington. Because we want to be as prepared as possible for that, that biggest event that could happen. So those tsunami waves in that scenario could reach our outer coast in about 3.5 to 4 hours. Again, more time than Cascadia, but not a ton of time if we are trying to evacuate folks out of, the marina areas and low-lying areas like that. We also know from modeling now that the wave crest is going to be leading. So instead of having the drawback of the water to warn us that something's coming, we are just going to get that first wave hitting us. So again, those alerts are so important. I have here an image from some of our very localized modeling for the downtown Westport area showing what that Alaska scenario potentially could look like. And what this shows is that we could still see several feet of inundation on land in parts of Westport and, theoretically other parts of the outer coast, depending on how low lying they are and depending on what that Alaska event looks like. So it's something that we want to keep in mind even when we are talking about these distant events, because several feet of water, when it's moving fast and it's, got a lot of force behind it and potentially, debris and things like that, is still going to do damage. And we still don't want people, in the path of that water. So this here, speaking of California, they were hit pretty hard by the 2011 Japanese tsunami. Crescent City, especially if you know anything about Crescent City and tsunamis, they are situated in just the worst place to have a harbor because they get hit by just about every tsunami that travels to the West Coast. So these videos here are just showing what that wave looked like that came all the way from Japan. We had, again, 11 or 12 hours notice, very, much decreased in the energy and the power of those waves. And yet they still did a lot of damage in Crescent City. You can see that this wave, even traveling up kind of this channel, is knocking boats about, is damaging docks and pilings. If boats are pulled from their moorings, they're now debris that's being knocked against other things, being thrown on land. So they saw quite a bit of damage, about $100 million in damage, just from that event. And as I mentioned earlier, our most recent tsunami was not from an earthquake at all. It was from an underwater volcanic eruption, which we didn't really know what to do with because we basically model for earthquakes. So if you remember that back in January of 2022, there was this pretty impressive volcanic eruption in Tonga that was actually, you could see it on satellites. It was quite large, and it caused a tsunami that traveled across the Pacific Basin in kind of the early hours of what for us was Saturday morning on January 15th. Now that actually put us in a tsunami advisory, and I'll talk about kind of the different tsunami alert levels in a little bit, but that took us by surprise. Thankfully, given just kind of our location and the geography and bathymetry off of our coast, we saw waves of about a foot, but we here in Washington didn't see any damage. No one was injured. California, on the other hand, especially kind of Crescent City and Santa Cruz and Ventura harbors, they saw waves of about 3 to 4 feet, which for something that traveled that far across the Pacific Basin, pretty impressive. I include these two videos to show what the power of those smaller waves can be. In the video on the left, you can see how much force is behind those waves when they're coming in. They're pushing around these huge barrels and hitting with a lot of force into the walkway. So you would not have wanted to be on that beach, even though, you would have been told, you don't need to evacuate, just need to stay off the beaches and the water. And unfortunately, we had a lot of looky-loos who went down to the beach to see the tsunami come in, and this is why we don't want you to do that. The other video I think is even more powerful, because this is just showing one of the marina parking lots that's been inundated by water. And it looks like that water is not moving. It looks like you could wade through it if you needed to. But if you watch at the back of the video, when it zooms in here, you can see that some of those parked cars have been lifted up by the waves and are floating away. That means that water is actually moving pretty fast, and it has a lot of force behind it. You also don't know what's in that water. It's pretty murky, which means there could be all sorts of debris, sharp objects, objects that could tangle you and pull you under in that water. California didn't see as much damage this time, only about 10 million in damage versus 100 million in 2011, and that's because they mitigated a lot of those impacts post 2011. But again, it does not take large tsunami waves to do damage and to put us in danger. So let's talk about those natural warning signs and those official alerts that I have said are so important. So for those local tsunamis where we may not get that alert in time, or we may not get it at all, those natural warning signs are going to be our best warning. Of course, if it's something local, if it's a local earthquake, that shaking is our best warning, maybe our only warning. So long or strong shaking on the coast, we of course want you to drop cover and hold on first to protect yourself during that earthquake. As Brian said, you're not going to be able to evacuate to high ground if you have a broken leg. We want you to protect yourself first, and then as soon as you can walk safely, grab your go bag, head to high ground. Don't wait for an alert, coming in through an official method. However, if you don't feel that ground shaking, maybe the tsunami is caused by some other, geologic feature or something, or it's a distant tsunami that's coming and you don't have a way to get official alerts, there are other natural warning signs that can be useful to you. The first is obviously a sudden rise or fall of the ocean. So if it's that trough leading first, you're going to see the water pull back really, really far, much faster than a normal low tide. It's going to leave, marine creatures flopping on the beach, and you're going to know something weird is happening. You may also hear a loud roaring sound coming from the ocean. I've heard it likened to like an approaching freight train. And you may also just see the water behaving abnormally. If you're, if you've grown up in Washington, if you spend a lot of time by the water, you kind of know what low tide, high tide, tides coming in and out looks like. And if that water is like bubbling or frothing or in any way behaving in a way that you haven't seen before, and you're like, that gives me a weird feeling in my gut, that could be a sign that a tsunami is on the way, and we want you to get to high ground. For any of these, if a tsunami has not been caused and you have gone to high ground anyway, great, you practiced your evacuation route. There's nothing to be lost for thinking something's on the way and taking that protective action. Now, if we are going to get an official alert, those are at the very top level going to come from the Tsunami Warning Center. So there are two of them. The first is the Pacific Tsunami Warning Center in Honolulu, Hawaii. They are the international warning center for 26 member countries and Hawaii. That seems weird. It's partly because they are located on Hawaii. So if you are ever vacationing there, or if you ever move there, that's your warning center. For everybody else in the United States, especially for us in Washington, we are covered by the National Tsunami Warning Center in Palmer, Alaska. So they issue all of the tsunami products for Alaska, British Columbia, Washington, Oregon, California, all of North America. So if you are trying to figure out if something you heard about, some big earthquake somewhere caused a tsunami, you want to look at the National Tsunami Warning Center. They're going to be talking about if there's a risk for Washington. Now, what that process looks like for, let's say, an earthquake, not something kind of rarer like an underwater volcanic eruption, is that earthquake occurs somewhere in the Pacific. the National Tsunami Warning Center, their automated seismic sensors are going to alert them that an earthquake has happened. That earthquake is initially located and sized automatically. It says, yep, this earthquake looks like it was an 8.2 off the coast of Alaska. And then that information is compared to their historical database and different scenarios and determined if that is potentially going to cause a tsunami. And if so, who is in danger? Then they issue that initial tsunami bulletin with alert levels within 5 minutes of that earthquake. If, say, it is something off, the coast of Alaska, something close to us, it may be that we go immediately into a tsunami warning. Any location within a 3-hour window of the estimated time of arrival for the first waves of that potential tsunami is automatically put under a warning. Now, they don't know in that first 5 minutes if a tsunami actually has occurred. They are just looking at that earthquake and saying, well, based on the parameters and based on what we've seen in the past, it could cause a tsunami. But because we only have 3 hours in Washington, we need all of that time to, set off the sirens, to start getting people out of the inundation zone, to do all of the things that we are going to do to protect our people. So they got to tell us right away that this is maybe something. So they're going to put us in a warning. Then they're going to start monitoring tide gauges and dart buoys, which are buoys out in the deeper ocean that are, monitoring for tsunamis throughout that event to figure out if a wave actually has been created. And the minute that potential wave starts hitting dart buoys and tide gauges, or doesn't start hitting dart buoys and tide gauges if nothing was created, then they will start sending out additional bulletins. And those bulletins might say, hey, there's no wave, we're canceling that warning, or we're canceling that watch or advisory. Or it might say, yep, we see that a wave has been generated and we're starting to get information about it. So now we can adjust and we can say, Washington, looks like you're not going to be in a warning. You're under an advisory. You're not going to have major waves, maybe smaller waves, high currents. This is when it's going to arrive. That time between that first 5 minutes and when they can tell us that something has or hasn't for sure been caused or created, that can take a while. And that can, for all of you folks who are, watching your phones or the TV, the news or whatever, waiting to know for sure if something has happened, that can feel like forever. I know it can, because it feels like forever for us too. But just keep in mind that they have to wait until that potential wave hits sensors and they can get that information and process it. So it's not that they are withholding information that they have from us. It's just that we kind of all have to hold our breath until we know a little bit more. And then hopefully most of the time we get a cancellation and nothing has been caused. Now, when something happens out in that Pacific Ocean or nearby enough that we want to know about it, there are 4 tsunami alert levels that we may hear about. The lowest is an information statement, and these essentially mean for the public, no action needed. A tsunami has not been caused or created, or it's going to be so small that it's not going to reach Washington, or it's not going to do anything. It's going to be negligible. You mostly see these for earthquakes either that are off the coast of like Washington, Oregon, California, maybe Alaska, that are too small to create tsunamis, but they're large enough that we, the public, are aware of them. And the National Tsunami Warning Center wants to make sure that we know that they know something happened and that no tsunami has been generated. So they send those out to say, hey, we know there was an earthquake, don't worry about it. They may also send out an information statement for a larger earthquake or other event somewhere else in the Pacific that may or may not impact the folks close to it, but is not going to impact us. So it could be, there was a 7.9 off the coast of, Australia or New Zealand. As Brian said, they have lots of earthquakes, and that there may be local impacts for them, but there's not going to be anything for us. So we get an information statement. Now, if something does happen that may or may not have an impact for us, but it's a lot closer and we may need to act, they put us in a watch. Watch essentially says, keep paying attention. More information is forthcoming as we get it. Pay attention to your NOAA weather radio, to TV, to other radio. If you are in the inundation zone, maybe make sure that you know where your go bag is and that you're ready to take action if you are told to do so. This is the alert level that will always change once more information is known. So they're going to upgrade it to an advisory or a warning, or they're going to cancel it and say, nope, everything's fine. That watch is always going to change at some point because they know that we're all sitting there going, what's going to happen next? Advisory is what we were under for 11 and a half hours, I believe, during the Tonga tsunami. Advisory is really most important for anyone who is potentially going to be on the beach or very near the beach or like in a marina. So if you are a fisherman or you're a marina employee, or that's the day that you and your friends are going clam digging, like there was a clam digging on the day of the Tonga tsunami. This is really for marine and maritime. We know for an advisory that there are going to be strong currents and dangerous waves, but they're going to be either in the water or kind of very close to the water. Those waves are only going to be maybe 1 to 3 feet. Again, dangerous if you're near the water, but we don't have to evacuate everyone out of the inundation zone. We maybe want to get people off their boats and, closer to high ground. We want to get those clam diggers and folks who are enjoying playing around in the water that day closer to high ground. But this is not the one where we are sending out all the bells and whistles. That one is warning. So if we are under a tsunami warning, that either means that we know something big is on the way, or we are within that 3-hour window and we have to act because we need to get people to safety. So if we are under a tsunami warning and you are in that inundation zone, that means get to high ground right away. Don't wait for another alert. Don't see what your friends are doing or if your neighbor's evacuating, because you don't want to be the person who evacuates if you don't have to. We want you to get to high ground. Warnings mean danger, tsunami imminent. We're going to see flooding, powerful currents, wave heights above 3 feet potentially, lots of inundation. We want folks out of that inundation zone so that we know that you are safe. This is also the alert level where we are putting out all the bells and whistles. We are activating the tsunami sirens. We are sending out wireless emergency alerts, which Brian talked about earlier as one of the ways that you can get earthquake early warning. You will hear it on the radio, on TV. If you're not streaming, you have to be on an actual TV channel. But you are going to hear about this one. We're going to be pushing everything out for that warning. Oh, and I'm just going to skip through these. So again, for those distant events, those official tsunami alerts are so important to be signed up for, because if you don't know, or if you're not signed up, we can't tell you what's going on. And because every alert method has its kind of pros and cons, its strengths and weaknesses, we want you to be signed up for multiple methods. So we have all of these outlined on our website, mil.wa.gov/alerts. Really easy to sign up for some of these. What we recommend, first of all, there are some great kind of third-party apps that you can sign up for. We really recommend, if you are someone living, visiting Washington or Oregon, the NVS Tsunami Evacuation app. So it's available through your browser and also for Android and iOS. What's great about this app is that not only does it push tsunami notifications, so if we are under an alert level, that app's going to say, hey, something's going on. But also when you get into that app, wherever you're located, if you're visiting Ocean Shores for the day, you can click on your location and download their evacuation app or evacuation map. So anywhere you go in Washington or Oregon, you have that information kind of at your fingertips on your phone. The other thing we really want you to have, at your house, on your boat, maybe in your office or your school, is a NOAA weather radio. These are so important as a way to get those, not just tsunami alerts, but all other sorts of hazard alerts, information about what's going on in your area, different kinds of things that you might need to know about. NOAA weather radios are really, really handy. They come in all shapes and sizes, from cheap ones to expensive ones that have all sorts of bells and whistles. So it's whatever you want to purchase for yourself, but we highly recommend these as one way to get alerts. We also have our AHAB tsunami sirens. So AHAB stands for All Hazards Alert Broadcast. These are pole-mounted sirens that we have along both the outer and the inner coast. We have more than 120 of them now. If you are somewhere, especially on the outer coast, you can often see them as you are traveling. These are an audio alerting system. So these are only an outdoor for alerting purposes only, as kind of the backup to the backup. If you are on the beach and you don't have maybe a radio or a TV with you, maybe your cell phone is roaming or it's off. I mean, we know we have a lot of areas in kind of the more rural coastal zones that you just don't have cell phone coverage and you don't have internet. These sirens are to reach you in those moments when you have no other alerting method possible. They have an approximate range of about a mile in terms of how well you can hear them, but that depends a lot on the weather. On a clear, sunny, windy day, that wind can take that sound and take it miles and miles away. And on a really rainy day, you could be maybe 500 feet from the siren and not necessarily hear it. But it's something to have when you are on the coast. We here at Washington Emergency Management Division, we have the capability to remotely monitor, control, and activate those sirens. So we are the ones that if we are under a tsunami warning, we push the big red button and all the sirens go off. The local jurisdictions also have the ability to control their sirens. So if we are under an advisory and maybe, Westport wants to set off a couple of their sirens to get folks off of the beach or something. That's just an example. I don't think they're planning to do that, but they can do that if they want to. Now, we test the sirens daily as a silent test, so they don't make any sound. Monthly, on the first Monday of the month, as an audio test, they play the Westminster chime sound, so the do, 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 that kind of doorbell sound. And then we test them once a year on the Great Washington Shakeout with the actual wailing tone. And then following that, if you're close enough to kind of understand the audio in English and Spanish, you'll hear, this is a test of the Great Washington Shakeout. So keep in mind, you are going to hear the wailing sound on October 19th this year if you are near one of those sirens. So whether you feel that ground shaking, see something weird going on in the water, or you get an alert, know what to do when you're on the coast. Grab your go bag, head to the nearest high ground. Do not plan to evacuate by car, because if it's a local tsunami, we're going to assume that the roads are no longer passable. Power lines may have fallen down, the roads themselves may have buckled or kind of washed out, depending on the liquefaction in that area. And there may just be no way that you're going to drive. And if it is a distant event where we don't have that issue, we still want folks evacuating on foot if possible, so that we leave those roads open to emergency vehicles, to our emergency management folks, and to people who can't evacuate by foot or who have more difficulty doing that. So plan to evacuate on foot, because that's probably what's going to end up happening. And then when you get to high ground, stay there until you get the all clear from your local emergency management. As I said before, those waves can last for a long time. Some of those secondary hazards, that debris and hazardous materials that the tsunami leaves behind, might last longer. There might be fires. So it's not going to be safe to return to the inundation zone until your local officials have cleared it. And evacuating will take longer than you think. It's very important to know your closest evacuation routes and whether there is a map for them that you can download and take a look at. Very important to have your go bag packed and stored in an accessible place. And as I mentioned before, don't waste time confirming alerts with secondary sources, with friends, with family. If you get an alert, if you feel that ground shaking, if you see something weird in the water, that's your warning, get to high ground. And I'm sure that they are dropping things in the chat about how to get to some of those links. So you can look up where your various maps and alerts are. And again, mil.wa.gov/alerts is a great resource for signing up for all sorts of alerts. Now, When we talk tsunamis and earthquakes, and potentially with volcanoes too, really for any major hazard, plan to be on your own for a while in the aftermath. We never know what's going to happen, but we do know that some of these hazards can cause a lot of destruction. So hopefully, as you are coming to the end of this, you're thinking about, if you and your family are prepared, hopefully you're thinking about, well, how am I going to get alerted to the hazards in my area? Do I have a family emergency plan? Do I have a go bag packed and ready to go? Do I know my evacuation routes, and have I practiced walking them? How am I going to communicate with the people I love? And if I've done all of that and I feel pretty good, am I involved in preparedness on the neighborhood or the community level? What do the people around me need? So there are 3 steps really to preparedness. And the first of those is learning your hazards, which awesome. That's what you've been doing today. We have, of course, other hazards in Washington, meteorological ones like droughts, floods, storms, wildfires, potentially human caused ones like wildfires and pandemics. Knowing what those hazards are in your area is that great first step to knowing how you can get prepared and what you can potentially, potentially face in your daily life. Second step is making a plan. So knowing how you're going to communicate with the people you love, knowing how you're going to evacuate to, keep yourself and those around you safe, and then knowing how you're going to reunify with those people in the aftermath. Now, we talked family plans. That's really, that can be the people you live with, the people that you hang out with. Definitely that includes pets, really just the people that you care about. Having a workplace plan is also important because we spend a lot of time at work. And usually if we're at work, we are not with our families and we're not with all of our stuff. So we want to make sure that we've got stuff with us in case we end up getting stuck at the office. And then potentially other plans. So a plan for school, a plan with your friends, a plan for anywhere that you spend a lot of time. And then practicing those plans. Plans are great on paper until something actually happens and you're like, what did the paper say? And you don't have the paper with you. So practicing until you've got that memorized, until it's muscle memory, is really important. And then third, building your kits. So we kind of talk about 2 different ways to be prepared. The first is grab and go kits. Those are the things that you're going to take with you if you have to leave in a hurry. So if you have to leave your house in a hurry from a fire, or you are evacuating for a tsunami, anything like that you need to be able to actually physically carry with you is the kind of stuff that you want to put in your go bag. And then we also want you to be 2 weeks ready with supplies at home in case you get stuck there because of a winter storm, or you have to shelter in place for a while because of an earthquake and you can't, get anywhere because the roads are all blocked. That is the supplies that, you're going to have enough food, water, medicine, anything that you need for everyone in your family for that 2 weeks. That's a lot of stuff. You're not supposed to be able to carry it. But you want to start thinking about, what do you need to survive and thrive for at least 2 weeks? And if that feels overwhelming to you, don't worry, it is for us too. But we have a lot of ways that you can get prepared over time so that it doesn't have to be overwhelming or stressful or scary or cost a lot of money. So I really recommend going to mil.wa.gov/PIY. That's prepare in a year. We have a great program about getting prepared over the course of a year, or however quickly or slowly you want to do it, by completing different activities. And they just take a couple hours on maybe a weekend once a month, or however frequently you want to do it, to get yourself more prepared, because every step you take gets you more prepared. If all you do at the end of this, this webinar is put a pair of shoes under your bed in case of an earthquake, or visit one of the links that we've shared, you're more prepared. And that's awesome. And then start thinking about, especially if you are feeling pretty good about your preparedness level, who in your community is going to need extra help, whether that's with evacuating, with sheltering in place, just with taking care of their basic needs in the hours and days and weeks that follow those major disasters. And if you identify someone that you think is going to need that extra help, maybe reach out to them, or, form a community group and see what you can do to make sure that all of you are going to be able to thrive in the days and weeks that follow. Now, we've talked about a lot of different hazards and things that could, happen in your area where you live or work. If you are wondering whether those apply to you, a really great resource is DNR's Geologic Information Portal. It's at dnr.wa.gov/geology portal. What's great about this is that you can type an address in, whether it's your home or work or whatever, and you can see what hazards impact that area. So if you're wondering if you're in a lahar zone, you can look that up, or tsunami, or anything like that. Tons of information on this resource. So I definitely recommend playing around with that. And then finally, we've mentioned Shakeout several times. We really hope that everybody on this webinar, if you are not already registered for Shakeout, either your family, your community group, your employer, if you are not registered, we hope that you will register. Shakeout is the largest earthquake and tsunami drill in the world. This year, it is 10:19 a.m. on October 19th. As I mentioned, all the tsunami sirens are going to make the really loud, scary whale sound that day. Please don't call 911. But over 1 million people in Washington and millions of people across the world on that day are going to be practicing drop, cover, and hold on. So it's a great time to also practice that and be part of this big movement to be more prepared. You can register at shakeout.org/Washington and also learn a lot about Shakeout and about earthquake and tsunami safety at that website. And most importantly, as we move into kind of the Q&A, you can survive if you get prepared. We've talked about a lot of frankly, kind of stressful, scary stuff. But these are all hazards that you can survive if you are knowledgeable, if you are prepared for them, if you understand what can happen in the world around you. So here, again, are some of our resources. If you have questions that we can't get to in the next few minutes, please reach out to our team at public.education@mil.wa.gov. We're always happy to answer questions in probably a lot more detail than you're expecting. And you can also follow us on Twitter and Facebook at the accounts below. And at this time, I'm going to welcome Brian back over, and then we are going to open it up to questions. Ethan, are you able to unmute?
Yes. So I believe that Brian took care of the volcano questions that we had earlier in the chat, but a couple just came in. This one from Earl. Do we have to worry about dam failure during an earthquake or volcanic eruption?
That's a really good question. This is Brian again. So we have looked into this a little bit. The real experts on that are going to be the U.S. Army Corps of Engineers, Washington Department of Natural Resources. But the main things when it comes to dams, so one of the ways that dams are used during volcanic eruptions is actually they release some of the water in the lakes behind them so that they can actually act as a catch of lahars. They did this during that 1975 Mount Baker. Sometimes releasing all that water can actually be a huge hazard in its own because a lot of extra water coming down the slope. But in this case, if there's not a lot of water behind the dam, when the lahar comes through, it doesn't push as much water out of the way, so you're not as likely to get a dam failure. So that's kind of one of the interesting things on the Mount Baker lahar map, for example, because a lot of the hazards on the southern side of it that go down the river into, say, like Concrete and into the Darrington area, that only happens if 2 dams fail. So that lahar zone has a couple of complications to it. Now, recently they did a model using something called DCLAW, a new model that shows when a lahar from Mount Rainier comes down the Nisqually River, as long as some of the water is released beforehand from the Alder Lake Dam, that doesn't cause damage to the dam itself. And they're still looking into exactly what that means, but it is something that people are looking at. Now, for earthquakes, the dams in this area are designed to an earthquake standard, but they do have to be updated every once in a while. So there shouldn't be much damage to dams, not to worry about those as much, but they're designed for the faults known in the area. And the folks at our geological survey are always discovering new faults as well. So when that happens, our dams might be updated, rebuilt, retrofit, but they do that as quickly as possible. Based on the current dams, there's not much hazard. They're well aware of the earthquake hazard and they built to that standard. So I hope that helps. Like Alyssa said, we answer in excruciating detail sometimes.
And I'll bring this up again since Rochelle was talking in the chat. But Brian, can you talk a little bit about the relationship between a major tectonic earthquake or Cascadian slip triggering any volcanic activity?
Yeah, that's a good question. That's one we get a lot. So the biggest way to put it is that that's not something that's happened here before. We've had a lot of these Cascadia subduction zone earthquakes. We've had people living here for thousands and thousands of years. And I mean, if that had been the case, there would be a story about Thunderbird and Whale and Dachobed, about Thunderbird and Whale and Tahoma. And there's not. And then we've got some other examples of, say, in 2004, there was the huge earthquake in the Andaman Islands in Sumatra. Indonesia is the most densely volcanic area on the planet. It didn't trigger any of their volcanoes. Japan, 2011, their subduction zone, very similar setting to us, but more active volcanoes. It didn't trigger any of theirs. Is it possible? It is, but it's not something that's very likely. And yeah, what the USGS typically says with this is our volcano would pretty much need to have magma ready to erupt for any earthquake activity to actually set it off. And all of our volcanoes are in their normal state right now. All that magma is way below the surface, needs to break a lot of rock to get up close. But the thing I do recommend, and I put this in the question, in the response to the question as well, is, hey, make sure that your plans work in spite of each other. Make sure that if you have a way to get alerted for a lahar, for a volcano, it's still going to work after an earthquake, just in case, even though this is very low probability. So are all the things we're talking about today. And we're still asking you to plan for them. So make sure you know how you're going to get alerted. Make sure your evacuation route's still going to work just in case, because I mean, even in the event of severe weather, will your earthquake plan still work if there's a flood? Will it work if there's a volcanic eruption? So think about these things as you plan. What could go wrong? Yeah, just worst case scenarios. Plan them separately though, just in case. I hope that helps.
All right, we've got two more in the chat. This one's for Alyssa, a little specific, but are there any tsunami sirens along the Ship Canal and Ballard Waterway to the locks?
There are not. I can't answer that, thankfully. While we do have quite a few sirens along the inner coast, most of them are, I guess, upper Puget Sound, Salish Sea. The reason for that is that because the sirens are intended primarily to alert folks for a distant event, because for a local event, shaking is our warning. We don't have many of them down in the Puget Sound since we don't expect any distant event to really impact the Puget Sound. We have them kind of more up in sort of the island areas. That being said, that doesn't mean that we could not see, them being added in the future if there are local jurisdictions that want to, install them and add them to our network, that kind of thing, or if they've got sirens that match with our network and can be, already added to it. That's something that we've kind of been looking at slowly but surely, is kind of adding other things into the network to spread that alerting. But yeah, there are none there, just because any tsunami that's hitting in that area is going to be something local.
All right, thank you. And then the last one in the chat is from John. He asks, can you point us to resources that address mitigations to impacts of electrical infrastructures as a result of eruptions or tsunamis?
So I think a lot of those with the local infrastructure is going to be local, and you're actually power companies that are doing the work on that. So we're more very general hazard, but if you want to look at electrical infrastructure, yeah, your power company is going to be the one to go for that. We do work with them, but we're
Department of Energy.
Department of Energy potentially, or yeah, you're like TPU or Puget Sound Energy. Yeah, depending on which part of the state you're in. Yeah, we know there will be really huge impacts, and so do the power companies. They participated in like Cascadia Rising with us as well. But when it comes to individual mitigation, that's kind of their wheelhouse.
You may look, I think I've seen the links dropped in the chat, but is it Earthquake Country?
Yeah.
Earthquake Country may have some good resources on that website. And then I don't know if this will be applicable to kind of what you are asking about, but one thing that our tsunami program works on is creating tsunami maritime response and mitigation strategies for particular kind of ports, harbors, and marinas. We've completed 2, and we're working on 2 right now. And one of the things that those look at is, for that kind of specific area, what are potential mitigation opportunities? And those are primarily maritime related. So it's looking at, do you have, electrical or fuel, something like that that's right on your docks that you can move, or is there a way that you can strengthen it, harden it, lift it up out of, potential, distant tsunami waves, that kind of thing. That may be helpful to you, or maybe an interesting read. The 2 that we have finished are on our website, and the other 2 that we're working on should be out, I think, at the end of this year. So that's something worth looking at, is a lot of the tsunami mitigation that's not related to kind of evacuation, is very sort of maritime focused, in making sure that our port and harbor infrastructure is as resilient as it can be. So I would look there and see if there's anything that's kind of close to what you are thinking of specifically.
And then just had another thought on volcanic ash there. So you can look at the USGS's ash hazard page. They have a lot about just kind of what the impacts might be. That would be the resource I'd recommend. But some of the hazards with that are kind of, if there's a lot of volcanic ash flying around, it's not really good to do a generator because it sucks in air and it can actually damage the engine of the generator. So kind of making sure those are covered in a way that's not a fire hazard. Yeah, it can be really challenging, and a lot of these things haven't really been looked at in the US because of just the lack of volcanic ash flying around. But as was mentioned in the chat, already have we do work with a lot of other countries on this and see kind of what works there, where eruptions are more common. But yeah, can say for sure, like to some of the power companies in Pierce County did participate in an exercise where they're looking at like what the impacts of a lahar would be coming down the major rivers with a Mount Rainier eruption, and just kind of to the infrastructure. And there's a lot that is difficult to say for an individual level what you could do to mitigate, but the power companies are working towards it. Yeah, it's complicated. Good question.
All right, thank you. That is all we have in the chat.
Awesome. Well, thank you all so much. I know that was a lot of information we threw at you, and a long webinar. So whoever stuck with us till the end, give yourself a gold star. And thank you so much. Like I said, if you've got questions, or if you're like, oh, what was that resource? Or, oh, did they have a resource about this? Please reach out at public.education@mil.wa.gov. And we've got lots of different links and resources that we can provide you.
And don't forget to do the shakeout.
Don't forget to register for Shakeout, and we will be drop covering and holding on with you on 10/19.
Thank you all so much, and great questions.
Thank you, everyone.